Hello everyone, today we're going to be talking about the elimination method, what it is, situations you might run into, and how to use it. So when it comes to elimination method today, we're going to talk about linear equations. So equations with two variables, we'll just use x and y, but it could be a, b, or whatever else. And we're going to have two equations today, and we're going to find where they intersect each other or where they're the same. So looking at this, let's start off with an example. Let's have 2y plus 7x equals -5. And then for our second equation, we're going to have 5y minus 7x equals 12. So when I say we're going to solve these, what that's going to look like graphically is you're going to have two lines, and they're going to have some sort of intersection. And the intersection will be an x value and a y value. And we're going to use the elimination method today to find those values. So when it comes to two equations or more, there are certain properties that they have, ways that you can work about them. And the ones we're going to focus on today is that if you multiply an entire equation by itself, all over, it's still the same thing. So what that looks like is, let's say we have this first one. We can multiply, for example, this whole thing by 2. So let's take this, multiply it by 2. Okay, so that'd be 4y plus 14x equals -10. And that just means that these two equations here, 2y plus 7x equals -5, is the same thing as 4y plus 14x equals -10. You multiply both sides of the equation by the same number, making the equation equal to itself. And the other factor I want to talk about today is that you can add these together. And that we'll see that through the examples, but it'll make more sense. So looking at this one, I would call this situation 1. There's going to be three situations you'll kind of run into that you need to be familiar with. Situation 1 is where either you have the y values having the same coefficient, which just means the number right in front of it. And this is an example here. We see that x, we have 7 in front of both x variables, so they have the same coefficient. So we'll call this one situation 1, and it's normally the easiest that you'll run into. So like I said earlier, you can add these equations to each other. So we're going to draw a little line below it, and we're just going to add them. The reason we're adding them is we're trying to get rid of one of the variables, so then you can solve for the other one. And we see here that we have a positive 7x and a minus 7x. Because we have 2y plus 7x and we have 5y minus 7x. So when you have a positive 7 and you add -7, you're going to cancel those out and you're going to have no x's left, leaving you with just y's. So we can do that then. 2y plus 5y, that's going to equal 7y. And then we know that plus 7 plus -7 would be 0x. So we can just write that in just so you understand, but you can just ignore that. And then we also have to add up this right side. -5 plus 12 is 7. So what we're going to have left is 7y equals 7. Divide both sides by 7 to get y by itself. Y equals 1. And now that we have y equals 1, what we can do is we can pick one of the two equations, whichever one might seem easier for you, and we can plug that in to the y value and then solve for the x value. So keeping that in mind, let's see here. Let's just plug into the first one. Not sure if that's necessarily easier or harder, but let's plug it in. So 2y, 2 times 1 plus 7x equals -5. So we're going to have 2 plus 7x equals -5. So again, this 2 from the left side to the right side, we have to subtract it. 7x equals -7. Divide both sides by 7 to get x by itself. We're going to have x equals -1. So what I'm saying here is that we have our x value and our y value. We can write it as a set of coordinates. X we see is -1, and y we can see is +1. So this graph doesn't work necessarily the best because it's in the top right plane is what it looks like. But we would say this is -1 and this is +1, and that's that point of intersection for the two equations. So that's what we're doing when we're using the elimination method or whenever we're just solving a set of equations together. So now that we've looked at the first situation, let's keep in mind another situation you might run into. I'll call this one situation 2. And when I write this, it'll become apparent what the issue is. So let's say we got 3x plus 4y equals 52 for the first equation. The second equation is going to be 5x plus y equals 30. So we know that the first situation came when we had the same coefficient for x or the same coefficient for y, making it very easy for us to cancel it out and solve for the variables. In this situation, what we're looking at is that x and y, for both equations, neither of them share the same coefficient, so we can't just cancel it out. So what we're going to do in this situation is we're going to see if we can just multiply one of them to get up to the other side, basically, for the coefficient. And what I mean by this one is you can see we have y here, which is 1y, and we want it to be 4y, so that we can cancel out easy. So we're going to transform this bottom equation by multiplying the whole thing by 4. So 5x times 4 is going to be 20x. Y times 4 is going to be 4y. And then 30 times 4 is 120. And now another issue with this is, well, I suppose when I said that you can add equations, you can also subtract them. So we'll do that just as a point of example. Otherwise, you can multiply this whole thing by -1 and then just add it. It's doing the same thing in spirit. So let's just write these out again. We got 3x plus 4y equals 52. Then we have our transformed equation that we just did above, which is 20x plus 4y equals 120. So just like you can multiply these equations, you can also, well, just like you can multiply, add, you can also subtract them from each other. So let's look here. We got 3x minus 20x, that's going to be -17x. And we know that these 4's will cancel out because +4 minus +4 equals 0. And then 52 minus 120 would be -68. And looking at this, we're going to divide this by -17 to get the x by itself. So we're going to have x equals -68 divided by -17, which is +4. And that's going to be one of our solutions. So I'll just underline that in red. And now with that in mind, we're going to plug that into whichever equation seems to be a bit easier to find which y value works. So since that bottom equation is kind of larger in this case, let's just plug it into the first one. I think that'd be easier. So we're going to take that x, plug it into that first equation, and solve for y. Okay, let's see, we got 12 plus 4y equals 52. And 4y equals 40, as you're going to subtract 12 from the left to get rid of it, which means y equals 10. So if we're going to have our little point of intersection here, definitely not drawn to scale, but we'll say that x is 4 and y is 10. So the point of intersection is 410 for those two equations. Now we're going to go through one more example, which we'll call this situation 3. And this is going to be the most difficult situation you'll run into. But all we're going to do is use the skills that we used before with a little more math involved in it. So let's look at an example that we can work with. Let's say we have 4x minus 7y equals 2 for our first equation. And for that second equation, we're going to have 3x minus 3y equals 6. So we know that the first situation you have a common coefficient. The second situation you can just multiply one of the equations up to the other one and then just solve for the variables that way. This situation you cannot do either of those. So we don't have shared coefficients. We can't just multiply one of these by a whole number, an integer, just to make it very easy. So what we're going to do is take the common multiple, the lowest common multiple of either of the coefficients, and we're going to solve it that way. And it might sound confusing, but let's just look at it and keep it in mind. So we can see that we have 4 for the first x coefficient and then 3 for the second x coefficient. When it comes to 4 and 3, we're going to find their lowest common multiple. So we got 4, 8, 12, looking at multiples, just counting them up. Then you got 3, 6, 9, 12. So we can see that that lowest common multiple is going to be 12. So this means that we're going to have to multiply the first equation by 3 to get 4 to 12. Multiply that second equation by 4 to get 3 to 12. So we're going to do that quick. Let's write that out. So first one, we're going to multiply by 3. Second one by 4. And now let's put this in red, make it stand out a little bit. 4x times 3 is 12x, minus 7y times 3, which is 21y, equals 2 times 3, 6. And then next one we can look at is 4 times 3x, 12x, which we have the matching 12x's, that's what we wanted, minus 3y times 4, which is 12y, and then 6 times 4, which is 24. So these are the new equations that we're working with. And all we did was multiply both of our equations to get their least common multiple. So then we can easily cancel out the variables. So let's solve this one. Look at it. We see that we got 2 positive 12, so we're going to want to subtract the bottom one by the top. So we're going to get 0x as a result. 12 minus 12 is 0. Then we got negative 21. We're going to minus, and we'll write this out, negative 21 minus negative 12, which is the same thing as saying negative 21 plus 12, which is negative 9. So we're going to get minus 9y, and then 6 minus 24 is negative 18. So what we have here is minus 9y equals negative 18. So you get y by itself. We're going to divide by negative 9. So we got y left over. Negative 18 divided by negative 9 is 2. So now we solve for one of our variables. Let's plug it into the equation to find the second variable. So looking at the two equations that we're kind of working with here, I would say the bottom one seems to be a little easier. You kind of just got numbers that seem to be working out with each other. Not the best explanation, but you can kind of eyeball it and see which one just feels easier. Nevertheless, you're going to get the same answer no matter which one you plug in, so it doesn't really matter at the end of the day. Okay, let's see, we got 12x minus 24 equals 24. And then we're going to 12x equals, we're going to add 24 to bring it to the right side, so we have negative 24 on the left, 48. And that's going to come down to x equals 4. So now we got our two sets of points. We have x equals 4 and y equals 2. Drawing that on a little graph over here. I'm going to have our two lines of intersection. And let's see. X equals 4. Y equals 2. We can write that as coordinate points 4, 2. So that's all that really comes down to it when we're working with the elimination method. You got the three situations, which we can go over quickly again, quick. Situation 1, you already have shared coefficients, which is that number in front of the variable. Really easy to work with, just jump right into the math. Situation 2, you can multiply one of the equations right up to each other. And it's normally easy when you just have a coefficient of 1, so a variable by itself makes those equations very easy. Situation 3, you don't have a shared coefficient, you can't just multiply it up to it with a positive solid number, an integer. So you have to find the least common multiple for two of them. Just in those situations, look which numbers are smaller and have a least common multiple very fast. If you work multiplication quite often, you'll get used to that. But if you're not, you can just count them up and do it that way as well. So beyond that, there's not too much more of the elimination method. You can do it with more equations, but it gets complicated when you do that. And there's faster and more efficient methods. So that'll be in a future video. But if you're just getting into algebra right now and your teacher kind of sprung this on you as a new topic, that should be all you need to know. So thank you for tuning in. Make sure to like, subscribe, share with your friends, your teachers, and I will see you guys in the next one. Thank you.